In this video, we are going to talk about vertical stretches, compressions, and reflections of parabolas. And once again, we are still talking about this in that vertex form that we learned about last week. To start off, I'm going to go through a Desmos calculator to show you what this looks like on a graph. So here we have what we remember is our parent function, right? This is our original parabola that we're going to be comparing all of our transformations to. And now I'm going to show you the blue graph is what's going to have our stretches and compressions. And remember that we have that A. We could think of our equations in vertex form as this. You already learned about H and K already, so we're only going to focus on what A does. A is going to be multiplied by x squared. So A is 1 is going to be our original, because remember, multiplying by 1 keeps a number the same. Now when I make A bigger, and we're just going to make B 0. Right, so nothing's changing with H and K. I just wanted to show you that it could exist. But when A is 1, nothing has changed. When A gets bigger, we notice that that blue graph gets skinnier and skinnier. When I go back to 1, it gets closer, it gets a little bit wider until it gets to the red graph, our parent function. Then as I go closer to 0, we notice that the blue graph gets wider. So as A gets more than 0, it gets skinnier. As it gets closer to 0, it gets wider. And then when it's actually 0, that gives us a straight line. So that is the first thing. We call it stretches and compressions. When it's getting bigger, we are stretching our graph up and down like if you pulled on a rubber band, and it's making it skinnier. So we call that a vertical stretch. When our A is a fraction, when it's between 0 and 1, our graph gets wider, like we're pushing down on it from the top to make it wider. So we call that a compression because we are pushing down on the two sides. So when A is more than 1, it is a stretch. When it's between 0 and 1, it is a compression. Now we also could have negative A of x. And you notice that when it's negative, it's now been reflected over our x-axis. It's now flipped over. Now the same thing is still happening. When it's, in this case, it would be something like negative 3.1. It's still getting skinnier, so it's still being stretched, but it has also been reflected. And it's still being compressed, but it has also been reflected. So there's two different things that A can do to it. It can stretch or compress, and it could possibly be reflecting. And we knew that from when we first learned about graphing parabolas, and we saw that when you had a negative in front of the x squared, it flipped it over. It opened down. And so that's still the case here. So now that we've done some examples, we have our parent function, and let's predict what is going to happen when we have these different transformations. So when I have A equal to 2, since A is greater than 1, right? 2 is greater than 1, so it will be a vertical stretch. And we would say it's a vertical stretch by a factor of 2. So that factor tells us just what we're multiplying by, because remember, factors are numbers that we multiply. And let's see, is that going to happen with our graph? Is it going to be stretched? And you do see that the graph that I just showed is skinnier. It is more narrow than the original graph because it has been stretched. So let's look at the next one. I have A is 1/2. Now, 1/2 is between 0 and 1, so 0 is less than 1/2. 1/2 is between 0 and 1, so it will be a vertical compression. And then we still tell us how much it's been compressed. by a factor of 1/2. And let's see, will this new graph be wider? When we graph it, we see yes, it has now become wider. I want you to notice our vertex has not moved at all during this process. The stretches and compressions do not move our vertex, but they move the rest of the points on our graph. It's only those shifts that are going to move our vertex. So let's try one more. In this case, A is 4/3. Now, just because it's a fraction, that doesn't mean it has to be a compression. We have to look at the value 4/3. 4/3 is approximately 1.33. 1.33 is greater than 1. 1.33 is more than 1, so this will be a vertical stretch by a factor of 4/3. Remember, we're not just looking, is it a fraction or is it a decimal? We're looking at, is the value of that fraction or decimal more than 1 or between 0 and 1? And if we look at that graph, it has gotten narrower because it has been stretched vertically. Now, what do you predict would happen if I put a negative in front of this number? If I put a negative in front of this number, we are going to also have a reflection. So we could change this to say A is negative 4/3, so it will be a vertical stretch by a factor of 4/3, and a reflection over the x-axis. So when A is negative, we say that we have a reflection. So let's look at some examples. First off, these are kind of our notes that we have, so you could pause on this section and record this in your notebook. So we see some examples where A is more than 1, right? So we have 2 or 13.5, and you see that our red graph has gotten a little bit narrower, and we call that a vertical stretch. We could have where A is between 0 and 1, and you notice I represented it in a couple ways. We could write it as a decimal, we could write it as a fraction, and our graph is going to get a little bit wider. We call that a vertical compression. And then, in addition to those top two lines, we look, is A negative? When A is negative, we say that we have a reflection over the x-axis. And you can see how now our red graph is going down. And the reflection does not have to do with if it's a stretch or a compression. You can have a reflection and no stretch or compression. You could have a reflection and a stretch. You could have a reflection and a compression. So we have to look for those two things separately. So now we're going to practice sorting and identifying what types do we have stretches or compressions. So remember, all of our equations right now are written in the format y equals a times x minus h squared plus k. And the only thing that we are looking at in this case is the value of this number. After that, we will look at the other two numbers, but right now, when we're talking just about stretches, compressions, and reflections, we are only looking at A. H or K do not affect stretches and compressions. So to do this piece, we are just going to drag and drop to help us sort our different pieces. So in this case, A is 3.5. 3.5 is more than 1, so it is a stretch. In this one, A is 5/3, and 5/3 is more than 1, right? If I can use my calculator, and that would tell me that 5/3 is approximately 1.6 or 1.7. That is more than 1, so it is a vertical stretch. In this case, 0.25. 0.25 is less than 1. It is between 0 and 1, so we would call that a compression. is between 0 and 1, so we are going to call that a compression. Now I'm going to pause the video here and ask you to predict your sorting for the next two. Now for this one, it is -5, but right now we are not looking at the positive or negative because I'm not asking you if it's been reflected. I am only asking if it's been stretched or compressed. So because 5 is more than 1, 5 is going to be in our stretch column. So the graph is getting skinnier, even if it might be flipped over. The same here. R2 is going to be a stretch. Now these ones are written a little bit differently. These ones I've started writing in some H and some K values. But remember, we're only looking at A. So in this case, there is no number written there. When there's no number, remember an invisible coefficient we have could be 1. So because it's 1, it is neither, there is no stretch or compression. For this one as well, there is no stretch or compression. For this one as well, we don't see a coefficient, so I can put a 1 there. So when there's 1, it is no stretch or compression. Next, let's look at some graphs. Our blue is our parent function, right? So the blue is the parent function. In this case, the red has become skinnier, so we know that is a stretch. In this case, it has not gotten skinnier or wider. We see the vertex is actually what moved. When the vertex moves, it is not a stretch or a compression, so that's going to go in our neither column. And then here, we have the red graph is wider than our blue graph, so we're going to call that a compression. You make stuff wider by compressing it. Think about pressing down on some Play-Doh or something. You're making it wider and flatter. If you pull on it, you're going to make it skinnier. Lastly, let's look at if our graphs have been reflected. All we are looking for is if it's reflected over the x-axis, then A is negative, right? So A is negative. No reflection would be A is positive, right? So let's just look. Is A going to be positive or negative in these cases? So here, A is positive. So it's going to go in our no reflection column. Here, A is negative. So it is a reflection. A is negative, -0.25. So it is no reflection. A is negative, so it is a reflection. A is positive, so we have no reflection. There is no A value, so A value that we have that invisible 1 again. So when we have an invisible 1, there is no reflection. +2 means that there is no reflection. Now here we have a negative out front. That's like saying -1. When we see that negative out front, we know that we have a reflection. Now, which one of these graphs do you think shows a reflection over the x-axis? This third graph shows a reflection because now the graph is opening down instead of up. These two graphs still open upwards, so they do not show a reflection. And that is how we identify vertical stretches and compressions of parabolas.